plus or minus square root of, when I keep dot flip, it becomes 1 on top and a 2 on the bottom. And then 4 minus root 15 all over 8. Okay, I'm just going to leave it like that. All right, again, on the test, that's okay with me, all right? Because ultimately, like if we needed this number, we would just plug this into our calculator and figure out what it is. So is it plus or minus? So we need to figure out, is this answer going to be the plus or the minus? So we go back and we think about where theta was, right? So remember theta was in here, right? Theta was somewhere in here. In fact, it was given to us that theta was between 0 and pi over 2, right?
Yeah.
But we're not interested in theta. We're interested in half of theta, right? So what I'm going to do is I'm going to take this original inequality and I'm going to ask myself, what would happen if I divide that by 2? I'd have to divide everything by 2. And so what that gives me is a new inequality. 0 divided by 2 is 0. Less than theta over 2 has to be less than, now this is the same as that, and you keep dot flip and you get pi over 4. So you're taking half of pi over 2, which is pi over 4. So my angle theta over 2 has to be between 0 and pi over 4. That's still in the first quadrant, isn't it? So like if this is theta, right? If this is theta, then theta over 2 is somewhere in here as well, right? Theta over 2. And therefore, sine of it is the y coordinate should be a positive number, not negative, because I'm still in this quadrant. Yeah? So what I'm going to do is I'm going to get rid of the negative, and I'm just going to say plus here, right? So I don't need the minus, or I don't have to write anything. This would be my answer. Or you could write this answer. Just take that out, right? And that's because we're in the first quadrant still. Let me tell you, this is where, this can be dangerous, okay? This can be dangerous. Let's say that what if your original angle was in the second quadrant? Okay, what if I told you, I gave you a problem, maybe we'll do an example here in a second. What if I gave you a problem and I told you that your angle theta was between pi over 2 and pi, right? So that means, you know, you're over here somewhere, right? Well, where's theta over 2? So take everything and divide by 2, where would you be? Theta over 2 would be bigger than pi over 4, right? But less than what? Pi over 2. Now you're in the first quadrant, right? Because pi over 2 is here, right? Pi over 4 is here. You're somewhere in here. Now that's going to change your analysis of things because your sine and cosine don't necessarily have to be the same sign, plus or minus. Make sense? Okay. All right, so we have to do cosine now. We need to do part D. What's the only difference? Well, there's two differences, I guess. For cosine of theta over 2, I still have plus or minus, right? Square root. The only difference in the formula is that this is a plus instead, right? That's the only difference in the formula. So I put there plus root 15 over 4, and then the whole thing divided by 2, right? Now, is it positive or negative? Again, we are in the first quadrant, aren't we? Theta over 2 is in here. Are y'all understanding this, theta over 2 being here? Yeah. Because the original angle theta was in here. So half of it will still be in there. So both cosine and sine are positive here because out and up, right? To the right, positive, up, positive. So we get rid of the negative there. Just take the positive answer. Okay. May I proceed? Let's do another one of these. If you look at the review for the exam, which I know you've all probably gone through it several times now, if you look at the review, the last problem on the review is basically 4 of these problems: 12A, 12B, 12C, and 12D. So on all of these, I'm giving you some information, and then I'm asking you for all of these things up here. You see that? Sine alpha plus beta, cosine alpha plus beta, sine alpha minus beta, tangent alpha plus beta. Then I ask you for sine 2 alpha, then cosine 2 beta, then sine of beta over 2, then cosine alpha over 2. So for those problems, it's pretty much what we're doing here, but even worse. So let me do one more of these, and then I say we do one of those. All right? So how about this? I'm going to tell you that tangent theta is 2/5. I'm going to tell you that pi is less than theta is less than 3 pi over 2. And I'd like us to find the same things that I asked for over there. I just gave you information about what angle? Tangent of what angle? Theta, right? And I want to know what sine of 2 theta is. Cosine 2 theta, right? Sine half of theta. Cosine of half of theta, right? So in order to answer those questions, I need to use this to figure out what sine of theta is and what cosine of theta is. Starting out with what quadrant we're in. Where are we? We're between pi and 3 pi over 2. So we're in the third quadrant, right? We're in here. Right? That's where we are. Now, tangent by definition, oh, you got to be careful on this one, is y over x, right? So 2 over 5 must be the y coordinate divided by the x coordinate. But we are in the third quadrant. So they're both negative. And it's hidden from you because 2 negatives would be a positive, which is why you're seeing a positive number here, right? So in actuality, our y is actually what? And our x is actually what? -2 and -5, right? Respectively. Right? Because you're in the third quadrant. If you don't catch that, everything else is going to be wrong, right? So be extremely careful here. That's why it's important to draw the picture of where you are, so that, you know, if you put here 5 and 2, that makes no sense. How could you be at 5 and 2? You're to the left and down, right? So this has to be -5 and -2. Now once you have that, you can find r, right? So using x squared plus y squared is r squared, we get, let's see, -5 squared plus -2 squared is r squared. 25 plus 4, right? 29 is r squared, and I take the square root on both sides. Am I moving too fast there, or is that all right? All right? I'm all right? And I didn't take the negative, right? Because r is always positive, right? So now we know r is root 29. And once we have that, we can talk about all the trig function values for theta. So we know what sine theta is, right? We know what cosine theta is. Sine theta, by definition, is the y coordinate over r. Our y coordinate's what? -2, right? Careful. -2, right? It's the y coordinate over root 29. And then the cosine is the x coordinate, -5 over root 29 again. We good? Now, just go to the formulas, right? Part A, sine of 2 theta. By definition, that's 2 sine theta cosine theta. What happened? Yeah. All right, and we know these, right? So we're just going to multiply. So we have 2 times sine theta, which is negative 2 over root 29, and then times cosine theta, which is negative 5 over root 29. And because of what happened last time, I'm going to just multiply all the way across the top, which would give me what on top? 20, positive, right? Positive 20. On the bottom, what's root 29 times root 29? Just 29. 20 over 29 is the sine of 2 theta. I just want you to kind of understand what we just did. This is theta, right? This angle right here is theta. If you were to double this angle, you would wind up somewhere, right? Sine of that angle would be a positive number, right? Positive answer. So if you double this angle, you're actually going to wind up back in the first quadrant. Because how do I know that? Because sine is positive, right? And if sine is positive, that means your y coordinate's positive, and so I'd have to be up here, not down here. Now, cosine 2 theta. I can use any formula I want, right? There's 3 of them. I can use whichever one I want. Now, what information was I given? Tangent. And none of my formulas, right? None of my formulas have tangent. For cosine 2 theta, none of them have tangent in it. So I've just got to pick which one. Which one do you want to use? Okay, yeah, we'll use that one then. How about this? 2 cosine squared theta minus 1. Let's use that one. Okay? So this would be 2 times whatever cosine theta is. We're going to square that. Whoa. We're going to square that and then subtract 1. All right, do we know what cosine theta is?
Negative 5 over root 29.
Very good. Negative 5 over root 29. 29 minus 1. And then when we square this, the negative is going to go away, right? So we're going to get 2 times 25 over 29. So we square the negative 5, we get positive 25. Square the square root, we get 29. Take away 1. That's the same as 50 over 29 minus 1. Right? Just multiply 2 times 25, get 50 over 29. Then we do a common denominator, 50 over 29 minus 29 over 29, because 1 is 29 over 29. And now 50 take away 29 is what? 21 over 29. That's what cosine is. Cosine of 2 theta. Okay? All right, part C. I need to erase some of this, so I'll give you a minute to catch up there. So speaking of ghosts, the story's a little late now, but when I was in my teens, I had a cousin who was like 4. I was in, I don't know, 16, 17, and I was downtown at my aunt's work at some building, right? And I'm sitting there, and I don't even remember what I was doing, and my cousin, little 4-year-old girl, was playing in the other room, like the conference area of this business, my aunt's business, right? And she's sitting there playing, and there was like a mirror, and like mirrors on walls, and she was like playing and stuff, and I heard her talking, and I'm just like, okay, she's a weird kid, whatever, you know? So then her mom finishes up, and you know, we're leaving, we're walking, we're getting in the car, and she starts talking about how much she enjoyed playing with that little girl. And so I was just like, okay, she was talking to someone, right? And then she goes on to explain about the girl, and my aunt didn't say anything about it, until later when her daughter wasn't there. And she was telling me that there was a little girl that had died in that building. And she had never told her daughter about this. It was weird shit. Anyway, what? That's crazy, right? I mean, I don't know. I didn't see the girl. I didn't see the little girl, but my cousin apparently did. She had a good time.
How old is your cousin?
Well, at the time she was like 4 or 5.
That makes sense.
Yeah. I mean, what does she have to lie about,
Yeah, just it was fun.
Yeah.
What did it
She wanted to go back and play with her, is what she was telling us. Okay, so part C. Sine theta over 2. So I'm going to use the formula plus or minus, right? Plus or minus. Plus or minus square root of 1 minus cosine theta all over 2. And I told you, for the test, just plug it in, right? Plus or minus square root. Do we know cosine theta?
Yes.
Yes, what is it?
Negative.
Negative, right? But be careful, there's a minus here, right? So minus negative 5 over root 29 all over 2. So I do want you to clean that up, please, on the test, okay? Like, make that a plus sign at least. Okay, is that all right? The double negative. Now, we have to determine whether or not this is a plus or a minus. So to do that, what I recommend you do on the test is go back to your original restrictions on theta, right here. Okay, and I'm going to write it down. Theta has to be between pi and 3 pi over 2, right? What we're looking for is what theta over 2 is, what sine of theta over 2 is, so what half of that angle is. So if this theta has to be between here and here, if I divide everything by 2, that'll give me the restrictions on theta over 2. So theta over 2 must be bigger than pi over 2 and smaller than 3 pi over 4. Right? Because when you do half of this, you're doubling the denominator, so it becomes that. Where is that? What quadrant is that?
It's in the second.
It's in the second quadrant, right? Because what? Pi over 2 is straight up, right? So you're not over here. 3 pi over 4 is right there. So you're somewhere in there, right? Somewhere in there? I don't know exactly where, but the angle right here, okay, that angle is, theta over 2 is somewhere in there. And we are looking for what? Sine?
So the y.
So the y coordinate of that point would be positive. You almost sold me on that one. Yes, the y coordinate there is positive, right? So I'm going to use the positive here. Got it? What will cosine of theta over 2 be, though? It'll be negative, because I'll be over here, right? So let's do that one. That's part D. So for part D, I want cosine of theta over 2, which is going to be plus or minus the square root of 1 plus negative 5 over root 29 all over 2. So the only difference between the cosine theta over 2 and sine theta over 2 is that becomes a plus. And so we're adding a minus, right? Adding a negative. So it is going to become subtraction in there. So plus or minus square root 1 minus 5 over root 29, then all of that over 2. You can leave that on the exam. But again, you have to analyze whether or not this is going to turn out to be positive or negative. Cosine of theta over 2 is the x-coordinate at theta over 2. We already know theta over 2 is right here. The x-coordinate there must be negative, and therefore I'm going to take the negative answer. Make sense or not? Yes? So let's act like this problem right here. Let's act like this, part D, let's act like that's worth 10 points on the exam. How much do you think I should take off if you get the plus and minus wrong?
2.
So out of 10 points, for just this problem right here, part D, you think if you miss that sign, I should take out how much? 1 point? You know what? Why don't you all just leave? Let's just take the rest of the semester off then. Let's do that as well. Everybody just get an A. Let's get the hell out of here. More like minus like 6.
6?
Yeah, I mean, this is the whole point of this thing. This is not hard. This is not hard. All I'm asking you to do is plug in cosine theta, which you should have right. All right? If you mess up the sign, you're missing the whole idea. The whole idea here is that you've got to determine the plus or minus. It's not a guess. It's not a flip of a coin. It's not what's happening to theta, right? It's what's happening to theta over 2. So you got to make that connection, okay? Good try, though. Yes. Yes.
At the very end,
Uh-huh.
it goes to 1 plus negative 5 over square root 29, and then it's 1 minus 5 over square root 29.
Uh-huh.
How did that?
That was a negative, right?
Yeah.
Cosine was, so when you add a negative number, it's the same as subtraction. That's all I did.
Okay.
Just like over here, it was minus a negative, right? Minus a negative became the plus. All right. Let's do a problem off the review. What do y'all think? Out of those two, let me see, that has tangent. Let's do one that has, okay, I'll let you choose. Do y'all want like that one with the tangents on it? Or do you want one with secants, or do you want one with sines and cosine? What do you want? You want secant? You think that that'll be okay? Mm-hmm.
This room needs new chairs.
Gaming chairs.
No, those are actually quite uncomfortable.
Are they? Okay.
Hey, at least they roll.
Yeah.
All right, here we go.
They mess up my back.
I have secant alpha. No, that's not secant alpha. Secant alpha is given to me to be 2. And I'm told that alpha is between negative pi over 2 and 0. Interesting, okay. And then I'm given some more information. Secant of beta, that's a different angle, right, is 3. And I'm told that 3 pi over 2 is less than beta, which is less than 2 pi. All right, that's what I'm given. Now, what am I asked to find? A lot of shit, okay? So let me look at what the instructions say here. There's A, B, C, D, E, F, G, H, I, something like that. See all the things we have to find? Right? All those things I'm supposed to find. A, B, C, D, E, F, G, H. I don't feel like writing those down on the board. You have them on the review, okay? Would you agree, though, that in order to figure those out, I'm going to need to know what sine of alpha is, what cosine of alpha is, what sine of beta is, and what cosine of beta is. And then I should be able to use the formulas, yeah? So I'm going to do drawings for both of these, recovering x, y, and r for both of these, and then once I get that information, just start cranking it into the formulas. All right. You have cosine, we just don't have sine, right? So to get sine, we still need to get the y coordinate, and that you can't do without drawing a picture and figuring out what quadrant you're in, right? Okay, so for this first one, let's figure out what quadrant we're in. Don't get tricked here. What quadrant is that? Fourth quadrant. Negative pi over 2. Remember angles, positive angles go this way, right? Yep. Negative angles go this way. So negative pi over 2 puts you down here. We're between here and 0, right? There to there. So that means we're in there. I'm going to draw it this way. You know, our angle's in here, right? Alpha, right? Alpha's in there somewhere. Now alpha has an x and a y coordinate. I'll have to figure out what those are. I'm told that secant theta is 2. I'm going to write that as a fraction 2 over 1. What is secant by definition?
The reciprocal of cosine.
It's 1 over cosine. What's cosine in terms of like x, y, r?
X over R.
Cosine is x over r. So secant is r over x. Exactly. This is r over x. Everyone buy that? Now you know what r is and you know what x is. Maybe, right? We need to make sure if we're about to say that r is 2, well, that's always positive. If we say x is 1, does that work in the quadrant we're in?
Yes.
Yes, x being 1 works. So that's here. Now we just need the y coordinate, which is going to be negative, right, when we get it, because we're down in the 4th quadrant. So I'm going to use my Pythagorean. X squared plus y squared is r squared. All right, x squared, 1 squared is 1, plus y squared equals r squared. R is 2, so 4. Y equals plus or minus the square root of 3, right? And we're going to take the negative. So I just took the 4, subtract 1, got 3, took the square root. So this is going to be negative root 3. Now, because of space, I'm going to try and squeeze this over here. What is sine alpha? What is cosine alpha? Why am I finding sine alpha and cosine alpha?
Because it's the angle that they gave you.
Okay, but why not? Why am I not looking for like cotangent alpha? Why is it that I'm just curious about these two things?
Because once you find those ones,
All the formulas involve sine and cosine, right? So that's why I'm going after these. So what was sine? Y over, so negative root 3 over the radius, which was 2. And then cosine would be the x coordinate over 2. That, by the way, is one of our common angles. You can tell by those answers. But that's not really relevant, because if I change that problem to a different number, like 3, then it's not going to work the same way. So we need to understand this part, right? All right, you ready for the next one? This right here is like the information I'm going to need moving on in the problem. Now I need to go talk about beta. So I'm going to draw another picture. This is actually getting fun, isn't it? Lie to me. Lie to me. Where are we? Where are we there?
Quadrant 3.
Is that 3? 4? There you go.
Mind if I join class again?
Yeah, come on in. We were just talking about how much fun we were having. What quadrant are we in? Fourth one. Okay, we're in the 4th quadrant. Somewhere over here, right? And I'm given some information about secant, so I'm going to write that as 3 over 1. I kind of wish that this problem would have been like secant alpha and maybe over here like tangent beta, just to have something different, right? But, you know, it is what it is. So this is r over x again, isn't it? And does that work? Yes. In that quadrant, my x will be 1, right? So this would be 1, and my radius is 3. So I can do the same thing I did before. X squared, oh, I don't need x. I know what x is. Well, I'll write it down. X squared plus y squared is r squared. So you get 1 plus y squared is 2 squared is 4. And so y, are we getting the same thing? Plus or minus root 3? Oh, it's 3 squared. Oh, that's right. Okay, sorry. It's 9 here. I messed that up. R squared, 3, 9, so it's 8. So plus or minus root 8, subtracting 1. And then because we're in the 4th quadrant, that y coordinate needs to be negative. So this y would be negative root 8. Understand? All right, so now sine beta, right? Beta, cosine beta. Sine beta is the y, which is negative root 8, over the radius, which is 3. Cosine is the x-coordinate over 3, 1/3. Here we go. We have everything we need, right? So now we just start plugging into formulas. Just plugging in. So let's start with A. A up there says sine of alpha plus beta. Sine of alpha plus beta by the formula is sine alpha cosine beta plus cosine alpha sine beta, right? That's the formula. You'll have that. So when I grade your test, if you mess this up, okay? If you mess this up, like let's say one of these things is off, but everything else is correct based upon that mistake, I'm not going to count the whole thing wrong, all right? That's why it's important for you to show your work during the exam, because if you make a small error over here that I can see, like, oh, you just forgot that, you know, that was negative. Yes, that's bad, but everything else you did correct after that, I'm not going to make you like completely suffer for it, all right? All right, sine alpha, here we go. Negative root 3 over 2 cosine beta is 1/3, plus cosine alpha, which is 1/2, and then times sine beta, which is negative root 8 over 3. Order of operations, these two, then add, right? So negative root 3 over 6 plus negative root 8 over 6. They have the same denominator already. So I put that together and I make that
Negative root 3 minus root 8.
good. Negative root 3 minus root 8, right? It doesn't become like negative root 24 or doesn't become negative root 11, right? Those are not like radicals, so we have to keep them apart and then put in here. I've been wanting to tell y'all something right when we get to that part, and I can't say it because it's 2022, and I'll lose my job.
What is it?
What I would consider funny, something funny. But if I say it, I'll lose my job. So I can't say it. And I have tenure too, so to have tenure and lose your job, that's a pretty big deal. But it is 2022, right? It's a crazy world we live in. I'm going to keep that there. All right, do I need to do cosine alpha plus beta? Do I need to?
Not really.
You understand what we have to do, right?